Okay, so let us start the lesson. So now this is the first time that you want to use the notion of integrals to calculate the volumes of geometrical objects. So the starting problem here is that assume that you have a function in 2D actually, because you know that when you talk about volumes, you have to be in 3 dimensions, yes? Because the objects in 3 dimensions can have volume. But let us assume that you have a function y equals to f of x, and then you have 2 points on the x-axis, say A and B, and then you have an area which is okay, so you have the area which is actually between A and between these two vertical lines, this x-axis and this curve, so this area. Okay, and what you are supposed to do, you start rotating this area about the x-axis, and it will generate a volume for you. We want to calculate a formula for calculating that volume. Yes, so drawing this by hand is not that easy, but let me try to motivate you. For example, I want you to imagine, so if you rotate this area here, so hopefully you realize that it will generate something like this. This generates a little bit bigger one, and then you will have something like this. Yeah, something like that. Yes, I don't know, can you imagine that? This becomes just a volume. And then you want to calculate a formula that we are able to use the formula and calculate this volume. This volume that you generate like this is called the volume of revolution. So you rotate something about the x-axis, and then you want to calculate the volume that it generates. And I don't know if you have already seen the video about the areas, how I come up with the area formula, that is more or less the same thing. So here, what I want to do, I want to partition this interval to smaller pieces. So let me concentrate on one of them. So for example, I start chopping up this interval to smaller pieces, and then let us concentrate on one of them. Okay? If you concentrate on one of them, if I ask you what is the shape, what is the name of this shape, of course it is not a rectangle, because it is not a polygon, because even though 3 sides are straight lines, but one side is curved, so we cannot give it a name. But if I make this a small, so for example, what I'm trying to do, I just want to make it a rectangle, and start imagining what will happen if I rotate this rectangle about the x-axis. Okay, I will definitely also generate a volume. This volume is not exactly the volume that I want, because I am ignoring this small part. Yes, so what I do if I generate this volume, I just want to ask you what that shape is, but then after that I want you to understand that the volume of that shape, whatever it is a little bit smaller than the volume that I want, because I'm ignoring that part. Yes? But the point is that by making these divisions smaller and smaller, what happens to my errors, the errors that I am making becomes also smaller and smaller. So if the number of partitions that I am doing here is infinitely large, then I can more or less ignore the error that is being made. So I can say that, okay, this number that I calculate in this way is a reasonable number to associate with the volume of that object. Yes, is the idea clear? Okay, so if the idea is clear, now my question for you is this. For the time being, ignore this error that I am making. This length, I call it delta x, a small change in x, okay? And let us concentrate that this point is itself point x. If I ask you what is the height here, what is the height? The function is f of x, this point is x, so I am interested to find this height. So what is that height? F of x. So this height is f of x. Now, my second question is that if you concentrate on this small rectangle, can you tell me what this shape will generate if being rotated about the x-axis? So assume that you are imagining, yes? It's a cylinder. Can you imagine that? So if you have a rectangle, and then you are actually rotating it about the x-axis. If that is just one single line, when you rotate it about the x-axis, it generates a circle. But here you have a little bit of thickness, so when you rotate that rectangle, it will generate a cylinder. Those thin cylinders are actually called washers, I think, something like that. Anyway, but that is or a disc. It's a very thin cylinder. And if you look at the formula of the volume of the cylinder, I don't know how many of you remember that, the volume of a cylinder, say V, is equal to the famous pi number multiplied by the radius of the cylinder multiplied by the height of the cylinder. So that's the volume of the cylinder. But now if I ask you to write the volume of this very thin cylinder, what do you write? That is not the whole volume, so let me call it delta V, meaning a small volume. This becomes the pi number, but multiplied by the radius of this thin cylinder. Can you imagine what will play the role of the radius of that generated cylinder? Yes? F of x, is that right? So this means that instead of r, I have to write f of x to the power of 2. Yes? And then I multiply it by h. H will be the height, which will go to play, which part is going to play the role of the height or the thickness? Yeah? Delta x. So I just multiply it by delta x. Okay? So if I ask you what I have calculated, this is, by the way, exact. If you are interested in calculating the volume of this rectangle being rotated about the x-axis, this is the exact value. But this is not the exact value for what I want to, because what I want to rotate is not this rectangle, is this shape, which I don't know even what the name is. I just want to rotate that one, yes? So it means that this is not exactly the volume that I want, so that is approximately equal to the volume that I'm calculating. Okay, but if delta x approaches 0, in other words, if I increase the number of partitions that I am doing, then I should, more or less, I am convinced that this is a good number to approximate that volume. But that volume is only the volume of one part, okay? I can repeat the argument for the next part. I can repeat the argument for the next part. The total volume that I am interested in will be the sum of all these small volumes, yes? So this becomes the sum of these small volumes, yes? For example, I just add them up. This becomes approximately the volume that I am interested in. But if I want to make it exact, I have to take the limit of this expression and then send delta x to 0. So this is the formula. I didn't prove the formula for you. I just want to motivate you. This is a reasonable definition for the volume of what I'm generating. Yes? Okay, and then if you're familiar, these kind of sums are integrals. So if I ask you how can I calculate this sum, if you have seen the previous video about areas, then this limit is actually the integral of the function that is here. Yes, so this becomes equal to the integral a to b, that function, whatever it is, and then dx. A and b are the limits where I start and where I end. So this is the formula that I get, and pi is a constant, so I can pull it out. So finally, the volume that we are interested in to calculate is pi integral from a to b, the function, whatever it is, to the power of 2, and then dx. Yes, so this is the formula for the volume of this shape that I have generated. Okay. So when I am allowed to use the formula, I am allowed to use the formula if the volume that I am interested in is derived by rotating an area about the x-axis. If I want to find that volume, I can use that formula. So let me, for example, give a simple example. Um, so if, for example, let us say that I have this function y, the function is f of x squared plus 1. So if you draw the graph of the function, it would be something like this. And then let us concentrate this part, which is from 1 up to, say, 3. And I want to take this region and rotate it about the x-axis to generate a volume. Then I want to use this formula to find the value of that volume. It's very simple. So what I'm supposed to do, I have to write the formula which is given in the formula sheet. So it is a pi. Don't forget about putting this pi here. And then you have integral. Here, 1 is the starting point, so it plays the role of this a, and 3 is the final point. But remember, this is not the function itself like area. If you want to calculate the area, you put the function itself inside. But if you want to calculate the volume, you have to find the function to power 2 and put it inside. So this becomes x squared plus 1 to power 2 dx. Actually, this is the new lesson. To calculate this is not the new lesson. If I want to calculate, if you remember, you have to find a primitive function for this function. When you found it, you replace the x value in the primitive function with 3, you replace x once more with 1, you get two numbers, you subtract them. So hopefully you remember. That's, by the way, in Math 3C as well. So today's lesson is finished here. The rest of it is we were supposed to calculate this integral. But if I want to calculate this integral, do you have any idea, to refresh your memory, how should I calculate a primitive function for x squared plus 1 to the power of 2? Yes?
Maybe just expand it.
Yeah, we have to expand it. There is no other way. So what I do, I will write like this. So I will continue here. So I put pi integral from 1 to 3. As you said, I will expand it. The first one squared is x to the 4th. 2 times the first one times the second one is 2x squared. And the last one to the power of 2, and then dx. Yes? So be careful about not missing anything there. So if I ask you know a primitive function for this, the answer is yes. These are so famous ones. Yes, you can immediately find the primitive function. But remember, you have a pi here. You open a pair of brackets. What is a primitive function for x to the 4th?
X to the power of 5 divided
By 5, which is 1/5 of x to the power of 5. A primitive function for this one is a third of x to the power of 3, but I have a 2 here. So this becomes 2 over 3, x to power 3. And a primitive function for 1 is just simply x. But I have to calculate it from 1 up to 3. What does it mean? It means that I have to replace every x with 3. I have to replace every x with 1. I get two numbers. I have to subtract. So I don't know how do you want to do it. So might be it's a good idea to write pi and then write it in this way. So pi multiplied by, I put 3 here. And then I put 1 there. Oh, sorry, this is 5. And then plus 1. But I have to calculate this a little bit. That numbers, let me see. So this is 3 to power 5 is 243 divided by 5. And then this is 9, 18, 21. Yes? So if I add them, it becomes 105. So 8 and 3, 4 divided by 5. Yes? And then I calculate this one. This is 1/5 plus 2/3 plus 1. I take the common denominator to be 15. So 3 times, and this is 5 times 10, 13, and this is 28. Yes? So I hope that I hadn't made any mistakes. So I haven't any mistakes. And then I subtract them. And then there's a pi here as well. So let me write everything now. Pi, this one, minus that one. These are just minor things. You just need to calculate this number, yes? So if you don't mind, you can just calculate it using the calculator. But you have to write volume units in front because you have calculated the volume. Yes? So this is a very simple exercise of today's lesson. So this is one type of problems that you can see. They give you a function and then they say that, okay, if I rotate this region about the x-axis, what will be the answer to the volume? But sometimes you can use this idea to calculate the famous volumes. For example, do you think I can use this idea that I described here to calculate the volume of a cone, for example? Because that is, by the way, a main interest to us, yes? If you want, you see objects in universe and then you want to calculate the volumes. But here, you just want to artifact the volume yourself. So this formula is helpful if you have already an area and you want to rotate the area to generate a volume. But now let us say that I have a cone in front of me and I want to find a formula for calculating the volume of the cone. So what do you do? For example, let me draw a cone for you here. So you know that if this is a cone, for example, and then I give you the radius of the cone, for example, if you whatever you want, you can measure. Well, of course, the main parameters of a cone is its radius and its height, yes? So assume that I give you r, I give you h, but I want you to find the formula for the volume. Okay, how can I use this idea that I described here to calculate the volume of the cone? So you see here, I have already my volume. But here I didn't have any volumes. I generated the volume, okay? If that is interesting or not, that is up to you. If that shape is an interesting shape to calculate the volume or not. But yes?
I guess you can draw a formula for a straight line and then do the same process.
Yeah, something like that. Because you need to imagine of a function so that after being rotated, it will give rise the volume that you want. Yes? So and as you said, that is exactly what we are going to do. So what we want to do, we want to imagine a function so that after being rotated about the x-axis, generates this volume for me. Okay? So what line is that? For example, do you think this line is good? Or I don't know, this line is good. Which one of these lines? First of all, do you agree that if I take this line from this origin up to some point, it becomes a right angle triangle? Do you agree with me that if I rotate this right angle triangle about the x-axis, definitely it will generate a cone for me, yes? I think that's obvious. But I don't want the volume of any cone. I want the volume of exactly that cone with the given radius and the given height. So I have to adjust my line in a way that after being rotated generates exactly the cone that I want to. And not all of them will generate that, yes? They can generate, flatter cones, wider cones or narrower cones, but I want exactly the volume of that one. So I have to fine tune the line. So can you fine tune it now? Okay, so let me just try to understand. So let me clean this and I try to understand the problem. So which line do you think I should write? Because I need a function. Oops. I need a function. So what that function is? So it is a straight line. Let us try to imagine that this is the line. Okay, but this is going to be y equals to what? So you need to tell me what should be the formula for the equation of this line so that after being rotated about the x-axis generates exactly that. So the starting point is 0. Can you tell me what is the final point? I should calculate that integral from a point up to a point. The starting point is more or less obvious. Yes, it is 0. But do you think I should go up to where? H. Yes, I should go up to h. Because this will play the role of the height of my cone. Yes. So this is supposed to be h. I want to have this to be h. what I want this to be,
R.
I want this to be R. Okay? So this means that if I ask you what are the coordinates of this point, what is the coordinate? The x coordinate should be h, the y coordinate should be r. So this means that this is not just any line passing through the origin. It should be a line that passes through the origin and also passes through a point whose coordinates are h and r. What are h and r? The same thing that I can measure on this code. Okay, now can you tell me what is the formula for that line now, the equation of that line? This is the equation of a line that passes through the origin. So you know that y should be the k value multiplied by x plus the m value. But the m value is how much?
0.
It's 0 in this case. But I also need k value. So what is the k value of this line? Yes?
R divided by H.
R divided by h. Yes, that's r divided by h. Yes? Because the change of y is r, the change of x in it is h. So that is the k value. So now I can clean this question mark. I can write it as r over h times x. So now we are hopefully convinced that this particular line, whose k value is rh, and r and h are the radius and the height of the cone, if being rotated about the x-axis, it will generate exactly the cone that I want to measure its volume. And now everything is ready, so I can use the formula. Okay, tell me, how should I write the formula? So the volume that I'm interested in becomes what? Becomes a pi integral from where to where here?
0
Zero.
to h.
0 to h. And then my function is squared. My function is this squared, is r over h x squared. And then I have dx. It's a very, very simple integral, yes? So I want to calculate this. Okay, so I told you that in high school, the only role played by this is telling you which is the variable. Here I have R, H, and X are all English alphabet letters, yes? But which one is the real variable? This shows that X is the variable. So everything else is supposed to be a constant. So if I want to do that, hopefully you agree with me, the best way is to expand this. So it becomes R squared over H squared, X squared, dx. But what can I do with this part? R squared and H squared, as far as this integral is concerned, are constants because the x variable is the only one. So it means that this is a multiplicative constant, so I can pull it out. So this becomes pi r squared over h squared, pi r squared over h squared, integral from 0 to h x squared dx. But this is a very, very simple integral to calculate. The primitive function of this is what? The primitive function for this is x to the power of 3 divided by 3, but I have to run it from 0 to h. Yes? I replace x with h, I replace x with 0, which of course becomes 0, then I subtract them. So then what happens? It becomes pi r squared over h squared multiplied by, if I replace x with h, it becomes h cubed divided by 3. I have to replace x with 0, but of course this is just nothing except 0. And then I do some simplification, so pi r squared over h squared, then I have times h cubed divided by 3. So I write 1 over 3 first. I write pi r squared, and this h cubed and h squared are simplified, 1 h is left. And if you look at the formula sheet, this is really the formula of the volume of the cone, of the radius r and height h. Yes, is that clear? That's one way we do it. Another problem I see, it is a level 3 problem in the book. We want to use the same idea to measure, to calculate the volume of a sphere. Okay, so then you have to visualize exactly the same thing. When I say that I want you to find the volume of a sphere, I have to give you the radius of the sphere, because the sphere is a solid object in 3 dimensions itself. So I need to show you this sphere and ask you, if you're a mathematician, calculate the volume. Yes? So how we should do that? So in this setup, we need a function in 2 dimensions so that after being rotated, it generates the sphere. Yeah, so let me just draw some sphere for you here. So for example, assume that this sphere is given. There is only one parameter of the sphere and it is its radius. So I give you this radius for the sphere and I ask you to calculate the volume of that sphere. Okay? But again, this setup is helpful if you think about this problem first in 2 dimensions and then rotate it about the x-axis so that it generates your solid object. But I don't think it is hard. So what is that?
A parabola with a maximum.
No, parabola does not generate a sphere. I have to draw it in a little bit tilted way, but a parabola being rotated about the x-axis does not generate this sphere.
Like I'm thinking if it's like this.
Yeah, your thinking is correct, but you have to be very precise. What I'm saying is that if you have a parabola is something like this. So it's not this, I mean, if I rotate it, I agree with you, you generate something like this. But this is not necessarily a sphere. I don't know what the name is. If you want, you can calculate the volume of that object, but that object, whatever it is not my sphere. But your understanding was correct. Not parabola. What should I rotate? Yes?
Like a sine function.
No, sine function. Why do you think like that? A sine function has the same problem as you said.
Oh, yeah, that's true.
You can calculate the volume if you are interested in, but that is not sphere.
Why is that not a sphere?
Well, that's a good question. I don't know how to answer that. But why is not a sphere? Because in a sphere, every cross section should be a circle. Yes? So if this is a challenging question for me. It was for me obvious that you have to rotate a semicircle to generate a sphere. Okay? But I don't know how to answer it now. So I was thinking that, okay, because if I have the cross, how can I answer it, by the way? So this semicircle, I hope that at least you agree that by rotating a semicircle about the x-axis, I will generate a sphere.
So how is this different from a parabola?
It's a good question, because if I want to prove that, so it means that in that object that I generate, I have to show that the distance from... Okay, so one thing I disclose, that is not a sphere, because if it is a sphere, it means that the distance from the center of the sphere to every point on the sphere should be the same value r. It should be the same thing, otherwise it is not a sphere, yes? And I hope that you agree this is not the case. Which one is going to play the role of your center here? Because when you say that this will generate a sphere for you, it means that the sphere has a center. I hope that you agree with me, you want to take this as the center somehow. But this is not the center. Why? Because I hope that because this is a parabola, there is no guarantee that the distance from here to here is the same as this distance, is the same as this distance, is the same as that distance. Is that clear?
Because it's not like
Yeah.
completely round.
Yeah, it's not completely round if you want to put it simpler. But so that is not a sphere. Yes? Unless you say that this is a sphere, but the center is not there. That's up to you to decide about that. But I hope that you agree with me that this is okay? So because at least when I start, this is a semicircle of radius, by the way. Which radius you want to take for your semicircle in order to generate your sphere? The same r. So if I start with a semicircle whose radius is r, if I rotate it about the x-axis, it will generate this sphere that I'm interested in calculating its volume. Yes? Is that clear? Okay. But this problem is a little bit harder because probably it's not that famous for you. It's also famous, but let us see what do you do. Okay. Now I understand that my setup should be like this. So I start from here to here, then I will draw a semicircle. If it is a semicircle, you told me that the radius should be r, so this point is positive r, this point is negative r, and this point is also positive r. You might say, Babak, why are you choosing this one? Why don't you choose this semicircle? Do you think that this is also working or not? I choose my semicircle here, and then this becomes 2r. and then this one is r. I hope that you agree. It doesn't matter if I rotate this one about the x-axis, it will also generate the same sphere. But the point is that calculating it with this one is harder. Why is that? Because if you want to find the function whose graph is this, it is harder to understand the graph of the function. And even if you succeed to find, which is not that hard, you can find it, but calculating the integral for that is harder. Okay? But if I use this symmetry, I can do it easier. So what I'm saying is that this will generate the sphere. This will also generate that sphere. So technically speaking, there is no difference if I start with this or if I start with that. But from calculational points of view, if you decide to choose that one, then you will make life harder for yourself. Okay, I can elaborate a little bit later about that. So this is the best one that I will choose. Okay. And by the way, do I need to do that? I can use symmetry. Do you think that I can just take this one and rotate this? It will generate a semicircle. But then semisphere. Yes, and then I multiply it by 2, I get the volume of the holes. So that's optic. But let me first, anyway, I want to do you remember in the case of the cone, we have to find the function. So now, can you tell me what is this function? What can I write for y is equal to what for this function? Because I need that. Yes, I need that function so that I can put it into integral and calculate the volume. But what that function is? What is the meaning of that? When I ask you what is y, it means that if I give you x, what is y? That is the meaning of function. When I ask you to write y equals to f of x, it means that if someone gives you x, how do you calculate y? That is the meaning of function, yes? So if I give you x, how can you calculate y? So exactly in this setup, r is given, or you know about r, you know about x, you want to calculate the question mark. That is the meaning of what function is. So how can I calculate y if I give you x and if I give you r?
Root minus x power 2 plus r power 2.
Not plus. Yeah, you're close. But how should I do that?
Like circles, the formula is y power 2 plus x power 2 equal r.
Equal to r squared.
R squared.
Yes. Yes, if you know about that one. I mean, in Swedish education, they don't study the formulas for that. So let us start it from scratch. Okay? So how do you find y if I give you x and if I give you r? But this is a simple question. How can you find that? Isn't it clear? So let me give you a guide. I take this origin and connect it to this point. So what is the length of this blue line now? What is that? It's r, yes? It's r. And isn't it obvious now? I told you r is given, x is given, you want to find y. So that's just a Pythagoras theorem, isn't it? So this is a Pythagoras theorem. So I want to find y. Where is y? Y is from here to here. Yes? I want to find y, x and r are given. So what does it mean? It means that we know that x squared plus y squared is r squared. Yes? And then if I want to find y squared, so I just move x squared to the other side. And then if I want to take the root, it should be plus or minus in general. But which y is acceptable? Because all this semicircle lies above the x-axis, so the negative one is not acceptable. So I clean the plus minus, only the positive one is acceptable. So this is why. Is that clear? Okay, now I want to find the volume. So the volume is pi integral, by the way, from where to where in the setup?
Negative r
You can go from negative r to r, but then I would prefer to go from 0 to r, but remember to multiply it by 2 at the end. Because 0 is easier to calculate, to work with, rather than minus 1. So let us multiply it by 2. This 2 is coming from that fact. There is no 2 in the formula. Don't get confused when you see the video later. So then it starts from 0 up to r. So that is the reason. I should in principle go from minus r to r, but I do not have to. I decided to put 0 to r multiplied by 2 by using the symmetry argument. Yes? And then I need to write my function, not the function, by the way. The function is squared. Yes? The function squared is what? This is my function. I square it. So let me write it as square root of r squared minus x squared to the power of 2. And then I have dx. So if I can calculate this integral, hopefully you see the famous formula for the volume of the sphere. Do you remember something like that? Do you have anything in your memory about the volume of sphere? What is that? So it is 4 over 3 pi r cubed. So this is the formula for the volume of the sphere. So let us calculate to see if it really works. Okay, so I continue. The first thing is that we are lucky, this power of 2 actually helps me to get rid of the square root. So this becomes 2 pi, integral from 0 to r, and then I have r squared minus x squared dx. And if I want to calculate this integral, I have to calculate a primitive function for this function. Okay, so mainly people answered the second one right. If I ask you what's the primitive function of minus x squared, I think you will immediately answer me 1/3 of x cubed, and that is right. But if I ask you what's the primitive function of r squared, what's your answer? R squared x. So you are not confused to write r cubed divided by 3 because r is a constant. Yes, if I ask you what is the primitive function of 1, you say yes. You say x. Primitive function of 2, 2x. Primitive function of 3, 3x. So r squared is a constant. Primitive function of r squared is also r squared x. So I just write it r squared x here, but I have to run it from 0 to r. Yes? And then the rest of it is just simple algebra. So this becomes 2 pi, and now you see that y0 is better than minus r, because I don't need to be worried about the lower limit. When I put the lower limit, it's totally gone. So what I just want to do is just write it on. Okay? So then what happens, it becomes r squared. Instead of x, I put r. Okay, the battery is dead. So this is r to the power of 3. So I speak a little bit louder, but then I will change the battery. Okay, so here if I want to calculate this, what will happen? This becomes 2 pi, this becomes r cubed minus 1/3 r cubed. Okay, and then if I answer this one, so what is r cubed minus 1/3 of r cubed? 2/3, yes, of r cubed. And then 2 times 2 is 4 over 3 pi r cubed. So that's the famous formula for this. So if you don't mind, let me change this. Okay, I told you that, let us see that why, even though technically speaking, by the way, first of all, let me say you something. If you remember, I don't know if you have watched my video about the area, I never talked about finding the area of a circle, which is natural to think about. Why do you think I didn't do that? Now assume that you want to measure this area, yes? And then you multiply it by 2, it becomes the area of the total circle. Why do you think I have problems here? If I want to calculate area, this is, by the way, very counterintuitive. Calculating the volume was easier than calculating the area, which is probably a little bit counterintuitive. So why do you think I will have problems in calculating the area? So if you want to see why pi r squared is the famous formula for the area of the circle, you have to wait for university. Why is that? So if I ask you to calculate the area, what do you write? what do you write? You write the area is equal integral. There is no pi in the formula for that area. And then I have dx. Okay, where I start from, technically speaking, I start from minus r and go to r. If you want, you can go from 0 to r, multiply by 2 again. That's a minor thing. But what should I put here?
The function.
The function itself, not the square of the function. And the function is, itself is problematic at the level of high school. So for you, it is not easy to find a primitive function for this function. This is why, in this case, calculating the volume was simpler because of that power of 2, I got rid of the square root sign. But in calculating the area, there is no way. I have to live with this one. So that's why in high school, at least in Sweden, we don't talk about the area, yes, of the circle. Okay, that's one thing. One thing I told you that there is no difference, technically speaking, between this, in principle, technically speaking, there's a difference. In principle, there is no difference if I want to work with this semicircle and rotate it about the x-axis or work with this one. But from practical point of view, I want you to see the advantage of working this one. Yes? So let us try to see what happens if I insist to solve the problem using this. Okay, can you help me to do that? Okay, so here, if you want to do that, so first of all, you need to write your formula. So the volume is pi integral from a to b. Instead of f of x, if you don't mind, let me write y squared dx. Okay? But again, the question is the same. Of course, if I ask you to write something for a, in this new case, what do you write? 0. And for b, what do you write? 2r. That's okay so far. And then you have a dx. Then I have the same question for you. What is y squared here? Okay? So if I ask you what is y squared, how do you answer that one? What does it mean by y squared? I mean, again, the same thing. I give you some x, I don't know, some x here, and then I ask you what that y is. Okay? So how do you answer this question now? So let me put y here. Yes?
It's no longer the distance from the leader, it's from r.
It's from here. So you say that, okay, I just connect the center wherever it is to this one, and this is r. But let us see what happens. So this y squared becomes equal. So let me write. This distance is squared. But what is this distance now? Yes?
X minus r.
X minus r, no longer x. Yes? Because when I say this point is x, I mean the x coordinate is x. So it means from here to here is x. From here to here is r. So what is left for me is x minus r squared. And then plus y squared is what? Is r squared. Do you agree? And then I calculate y squared from here. So y squared becomes r squared minus x minus r squared. So it means that instead of working with the previous integral, which was r squared minus x squared, I have to work with this integrand. But let us just do that. If you insist to do it, it works. But you see that technically calculating this is a little bit more difficult. So what I have to put here, I put r squared minus x minus r squared. Okay? So if we can continue this calculation, if you don't make any mistakes, definitely the answer should be the same thing, yes?
Will be the root of r squared minus.
No, the root, but then I will raise it to power 2.
Okay, yeah, that's right.
Because what I need is y squared. So I didn't bother to take the square root and then take it over. The previous one I did it because I want you to see it, but then I need just y squared. Yes? By the way, let us calculate this one, not just as an exercise for calculating integrals. So how should I calculate this integral? Yeah?
You have to expand it first.
Yeah, we have to expand. There is no other way. So let me just do simple algebra here. So that's pi integral from 0 to 2r. And then I expand that so it becomes r squared. The first one is squared multiplied by a minus sign. 2 times the first one times the second one multiplied by a minus sign, it becomes positive. and then second to power 2 multiplied by minus sign becomes negative r squared dx. But then you see that this one and that one are not. And then let us calculate. Now a primitive function is easy to calculate. A primitive function for that is 1/3 minus 1/3 x cubed. What is a primitive function for this?
Rx squared.
Yes, because we don't care about 2r, that's a constant. A primitive function for x is x squared divided by 2, so it becomes rx squared. But the limits are not 0 to r, the limit is from 0 to 2r. And by the way, I don't need to multiply by 2 anymore because when I generate it gives me the whole volume. Okay, let us calculate. Again, the good point is that this is 0, so I don't need to bother about the lower limit because it becomes 0. So I only care about the upper limit. So it becomes minus 1/3 r to power 2r to power 3, which is 8r cubed. And then I put 2r here as well, so this becomes 4r squared multiplied by 2r, it becomes 2r cubed. Okay, so if you haven't done something wrong, this should be the same number. Let us calculate. Okay, so what happens? It becomes pi, this is 2, and this is minus 8 over 3. But it seems that we have made a mistake,
Yeah,
yes?
it should be 4r cubed instead of 2r cubed.
Ah, here.
Yeah.
Oh, okay, yes. 2r to power 2 is 4. Thank you. So this will change this one. Yes, that's correct now. Thank you. And then r cubed, I factored this out. Yes? So between these two, I factored r3 out. Minus 8 over 3 is left from the first one. Positive 4 is left from the second one. But what is the answer here? It's just 4 over 3. So it becomes 4 over 3 pi r cubed. So you see that technically it doesn't matter. And so in principle, it doesn't matter if you choose that semicircle or that one. But I think the calculation here was more straightforward than the calculation there. But both of them are correct. Okay? Any questions? Okay, so I will stop here. And there is one part of this chapter left only, and that is the applications of integrals in probability theory. And I don't know how much do you know about probability. Probably I will start from mainly scratch to talk a little bit about probability and then show how we can use this in a very particular and famous distribution, statistical distribution called normal distribution. Okay, so then this chapter will be completely finalized and we are left with only complex numbers. But that complex numbers is also very lengthy. Okay, any questions? Okay, I really recommend you please watch the videos that you have been absent for. Thank you.